Welcome back! We are going to continue on. We're actually skipping a couple lessons. So don't worry about it. I did this on purpose. It's okay. But you'll see what I mean in just a moment. First and foremost, let's start with our warm-up. Our fluency activity is, again, a sprint. And I'm pretty sure we're going to do sprints or sprint-like activities every day for this module since we're working on shapes and time and such. No, not shapes and time. Is it time too? There is some time in there. Shapes, partitioning those shapes, and time. There we go. I got words. Okay, let's start over. Welcome back. Okay, so today we're actually skipping ahead a couple lessons, and this is on purpose, and you'll see why shortly. Today's lesson is somewhat an extension of yesterday. So yesterday we were building shapes and we were looking at shapes to see the shapes that were inside of them, like what was used to build this shape. Well, today we're going to be looking at splitting those shapes into equal pieces called partitioning. But let me not get ahead of myself. Let's start by warming up with a sprint, which is in your Starry Night book on page number 63. Pink, yellow number, yellow trim. It looks just like this. And the directions read, write the unknown number. Pay attention to the equal sign. So pay attention to the equal sign and its location, the location of the equal sign. All right, so you should have your book. You should be ready to go. I'm going to go ahead and put 1 minute on the clock. On your mark, get set, go! All right, little tiny ring again, but that is the bell, and that does mean time is up. Let's go ahead and stop where we're at and check our work, see how we did. Come on. All right, so let's go ahead and check our work. We're going to write the unknown number. Pay attention to the equal sign. So, starting at the top, number 1, 4 plus 3 is equal to 7, 8, 9. 8, 9, 9, 7, 7, 8, 8, 8, 8, 9, 9, 9. The top of column 2, question number 16. 9 is equal to 6 plus 3. 9, 9, 9, 9. 8, 7, 9, 9, 9, 19, 19, 9, 5, 4. What do we notice starting here? Question 13 all the way to question number 20. The answer, you're right. The whole for each of these is 9. These are all ways to make 9. Isn't that cool? And some of them, such as these 3 here, even come from one number bond. For these 3 questions, this part are 7 and 2. Great work. All right, let's go ahead and continue with our lesson. Come on. Great work on the sprint today. What we're going to do now, as always, is our application problem. Yes, It lives in your Learn book on page number 221. I know that's a jump because we skipped. We skipped a couple lessons on purpose, very much on purpose. So this book right here, blue trim, blue number, page number 221. The digits are 221, and it reads, Peter set up 5 rectangular prisms to make 5 towers. He put a cone on top of 3 of the towers. How many more cones does Peter need to have a cone on every tower? All right, go ahead and work that out. Okay, so for the way in which I solved the problem, because we're going to check it together, I'm going to show you how I did it, we're going to compare, you're not going to erase anything, you're just going to add more information. If you got it wrong, then you're going to put the correct answer. If you got it right, you're going to write it in a different way. So this is how I drew it. I actually drew the little towers this time. Yes, I drew the little towers. I drew to show, now drawing a 3D shape, that takes a lot of time. So when we're drawing for math, for to show, for like a word problem, an application problem, we'll just draw the 2D version of what a face of the shape looks like. So let me show you. So here is my rectangular prism. And my rectangular prism is made of 1, 2, 3, 4, 5, 6 faces. What shape are these 4 long faces? Correct, they are rectangles. These 4 long faces are rectangles. And that's what I'm going to draw to represent my rectangular prisms. And then when I look at my cone, we know it's 3-dimensional because it's called a cone. What does just the front, if you're just looking at the front of cone, what shape, what flat 2D shape best represents a cone? A triangle. Excellent. So even though we know we're talking about 3-dimensional shapes, in my drawing I use their 2D cousins, because that's kind of what's like they're cousins. They're 2D cousins to help represent my picture. So here's my little tower. Here's my picture of my tower. Here's my rectangular prisms. Here are my cones. My picture and my number sentence say 5 minus the 3 that are already coned means that Peter needs 2 more cones. Peter needs 2 more cones. Good. All right, so yesterday, or last time we met, I should say, we looked at composite shapes, and we looked at building up shapes from a smaller shape. We also looked at larger shapes and saw, well, what smaller shapes can fit inside of the shape? Well, in this depiction here, we see the hexagon made out of triangles. And the question is, how many pieces, how many smaller pattern block pieces, triangle pieces did I use to make a hexagon? 6. Excellent. I used 6 triangles to make the hexagon. That is correct. Now, the question is this hexagon that's made out of triangles made out of equal parts? Are all the parts the same? They are, because I used 6 of the exact same shape to create this one shape. So right now, yes, I have 6 equal parts creating my hexagon. What about this version of a hexagon? What shape did I use to make this version of a hexagon? I used trapezoids. Correct. I used 2 trapezoids. 1, 2 to make a 1, 2, 3, 4, 5, 6-sided shape called a hexagon. Is this hexagon made of equal parts? Yes, because I used 2 of the exact same shape to build my hexagon. It is made up of 2 equal parts. Correct. What about this hexagon? Now this hexagon is made of 1, 2, 3, 4 parts. 3 triangles and 1 trapezoid. What's a trapezoid? I don't know. Trapezoid. Is this hexagon? Are there 4 equal parts used to make this hexagon? No. They're not, because I used two different shapes, which means that at least one of them is going to be sized differently than the rest. So this hexagon is not split into 4 equal parts. Now, what we're going to do is we're going to look at some shapes and we're going to identify them as being split into equal parts. And if they are split into equal parts, we're going to say how many. This is in your homework book, your Succeed book. Notice the red number, red trim on page 153. 153 looks like this. Looks like this. And we're going to start actually with letter G. I want you to take a quick look at letter A and see how it's modeled for you. Look at A and see how it's modeled for you. So if the answer is yes, we're going to write Y. And if it is yes, we're going to also write the number. Because if the answer is no, then we don't have to write anything else because it's not equal parts. So for the letter G, is this rectangle split into equal parts? Yes or no? Yes, this rectangle is split into equal parts. How many equal parts exist within this rectangle? 2. Good job. Now, let's look at letter H. Is letter H split into equal parts? No. Okay, you're right. No, letter H is not split into equal parts. This larger triangle is split into 2 smaller triangles, but those 2 triangles are not the same size. Now, I want you to think about it this way. Pretend you were looking to share something with a friend, a cousin, a sibling, and they cut it and they gave you this piece. Would that be fair? That wouldn't be fair, meaning they're not equal. It should be split into equal pieces. Do we fill out this line then? No, because it's not equal pieces. What about letter I? Is letter I split into equal pieces? No, and I'm going to tell you right now, you cannot cut a circle like this and get equal pieces. The only way to successfully cut a circle into 1, 2, 3, 4 pieces, you have to go through the middle. You have to go through the middle. You can either make a T or you can make an X. But making bars like that, these middle pieces are always going to be bigger than these outside pieces. So that's just a little note on circles. You can't cut circles this way and get equal pieces. Okay, what about this triangle here? Is this triangle split into equal pieces? Yes, this triangle is split into equal pieces. I would be happy if my sister gave me this piece and she had that piece. Now the follow-up question is, because we now know it's equal, how many equal pieces is this triangle split, broken, cut, partitioned, that's our math word, partitioned into? How many equal pieces is this triangle partitioned into? 2. Excellent. This triangle is partitioned into 2 equal pieces. What about this trapezoid? This is still a trapezoid. It's just a little bit taller. Is this trapezoid split into equal pieces? Gotta think about it. Yeah, no, this one, the line is pretty close. But it does appear that this piece is just a little bit smaller than that piece, meaning that no, it is not partitioned. It is not partitioned or broken, split up into equal pieces. What about this one here? What about this 1, 2, 3, 4, 5, 6? This hexagon. Is this the correct way to split a hexagon into 4 equal pieces? It is, yes. This is how you would split a hexagon into, and I told you already, 4 equal pieces. 4 equal pieces. You will use 4 four-sided shapes for four-sided shapes. 2, partition, split a hexagon into 4 equal pieces. Good job. All right, guys, so go ahead and flip to the back of that same piece of paper. We're going to do a couple more. Let's do a little bit more. All right, so here we're going to actually draw. We're going to draw to make the equal parts. It says draw one line to make 2 equal parts. What smaller shapes did you make? All right, so we have a triangle, and we want to partition it into 2 equal parts. We want 2 equal parts. Partition actually has the word part in it. Yeah. So, can I split my triangle here and make 2 equal parts? I cannot. No. What if I split my triangle here? Does this make 2 equal parts? It does. Now, what I will tell you is my line is not perfectly straight, but for the sake of trying our best, this works. Okay, guys? So if your line is not perfectly straight, it's okay. Now, what I want you to see with this triangle is I could have gone from any corner and split the side across from it, and I would have made 2 what? I made 2, like what is, so if I look at just one of these pieces, I made 2, what shape is it? Triangles. I made 2 triangles. Good. Yes, I made 2 triangles. I made 2 triangles. Now this time we're going to draw 2 lines to make 4 equal parts. And we're going to see what smaller shape did you make. Now this is fun. This is a rectangle. So there are several different potential right answers for this one, honestly. There are several different potential right answers. What I'm going to do this time is I'm going to, like folding a piece of paper in half, and like folding a piece of paper in half again. So just like when we fold a piece of paper when we're setting up to write a story, and we fold the paper so we can say first, next, then last, and we go, so you have this way and this way. Matter of fact, do I have it here? The last time we did it? Yeah. Remember we split our paper? And remember we folded our paper? So that we could have first, next, then last. We went across and down. Same thing. It's the same exact thing. So tell me, I made 4 what? What smaller shapes did we make? Even with our slightly imperfect lines, what smaller shapes did we make? 4 rectangles. Good. I made 4 rectangles. I made 4 rectangles. Excellent. Now, we'll talk later on this week about different ways we could have partitioned this larger rectangle into smaller rectangles, and it's going to be kind of fun. But guys, that gets us all set up for us to do some work independently now. You're all ready. You are ready. So let me show you what that is and where to find it. Show you what that is and where to find it. It is page number 223. It is front and back. During this module, the expectation is for you to complete your problem set. Not the whole, I know it shouldn't take you more than 10 minutes. You're going to do the same thing we did. On the front and on the back, you're going to write the number of equal parts in each shape, and then you're actually going to draw lines to make equal parts within the shape. You're going to leave your Nearpod alone to complete your problem set, and then return to your Nearpod to do your exit ticket. And I'm going to put this all on one slide. This can all fit neatly on one slide. So this will be a one slider today. But guys, that is all I have for you. I can't wait to see you in a little while. And until then,